In this video, we are going to find the maximum vertical distance between the line y equals x plus 2 and the parabola y equals x squared for -1 less than or equal to x less than or equal to 2. So, the vertical distance between these two curves is going to be the absolute value of the difference of their y values. So we can write this as a function f of x, where we take one curve, x plus 2, since we have that y equals x plus 2, and here we have y equals x squared. So we can take x plus 2 and subtract x squared. Now, what is this? This is minus x squared plus x plus 2. Now, we want to find the maximum value of f on the closed interval. So this interval here is the closed interval from -1 to 2. So we're going to use the closed interval method to do this. So what does the closed interval method tell us? Let's recall. The closed interval method tells us to find the absolute maximum and minimum of a continuous function f on a closed interval we have to do two things. First, we have to find the values of f at the critical numbers of f in AB. Now, what are the critical numbers of f? These are the numbers for which the derivative of f equals 0 for. So we'll see that soon in our example. Now, what's the second part? The second part tells us to find the values of f at the endpoints of the interval. So basically we have to evaluate f at a and b. Part 3 tells us that the largest of the values from parts 1 and 2 is the absolute maximum of f. And the smallest of the values from parts 1 and 2 is the absolute minimum of f. Okay, so let's apply this to our function. So we have this function f of x equals minus x squared plus x plus 2. So first we want to take the derivative of that function so we can solve for the critical numbers. So this is going to be the derivative of minus x squared is minus 2x. Then we have plus the derivative of x, which is 1, and then the derivative of 2 is 0. So f prime of x is minus 2x plus 1. Now, to find the critical numbers, I need to set this equal to 0. So I can add 2x to both sides. So we have 1 equals 2x, and I can divide both sides by 2 to get x equals 1/2. Now we have to check, is 1/2 in the interval minus 1, comma 2? The answer is yes. So we want to evaluate f at that point. So now we're on step 2. So, well, I guess first we're at step 1. We didn't actually evaluate f. So now I want to evaluate f at the point 1/2. Now what was f? F was this function up here, minus x squared plus x plus 2. So f of 1/2 is minus 1/2 squared plus 1/2 plus 2. So this is minus 1/4 plus 1/2 plus 2. So we can write all these as fourths so we can add them. So this is minus 1/4 plus 2/4 plus 16. Plus 8/4. So if we add this up together, minus 1 plus 2 plus 8 over 4, we get 9/4. Okay, now part 2 says we also need to evaluate f at the endpoints of our interval. So our interval was minus 1, 2, so we need to evaluate f at minus 1. So that would be minus 1 squared plus minus 1 plus 2. So that is minus 1 plus 2, which is 0. And then f of 2 is minus 2 squared plus 2 plus 2, which is minus 4 plus 2 plus 2, which is 0. So the third part tells us that the largest of these values is the absolute maximum of f. And we see here that the values we get are 9/4, 0, and 0, and 9/4 is the largest. So what does this tell me? This tells me that f has an absolute max at the point x equals 1/2, or the point is 1/2, comma 9/4. Okay, but what does this mean in terms of the original question? We were asked to find the maximum vertical distance between this line and the parabola. So what our answer tells us is the maximum vertical distance between y equals, what was the first curve? X plus 2 and the parabola y equals x squared on the interval minus 1, comma 2 is 9/4. And so now we have fully answered the question. If this video was helpful, feel free to like and subscribe.